Hey guys, it's Miss Johnson, and I'm here to bring you the first part of our section 6.2 notes. Today we're going to talk about transforming and combining random variables. So I want you to think back to chapter 2. In chapter 2, we talked about the effects of linear transformations on the shape, center, and spread of a distribution of data. So one of the things that we learned is that when we add or subtract a constant, it does not change the measure of the variability. So it doesn't change the standard deviation of a data set, but it does change the center. So it'll change the mean and it'll change the median, but it also doesn't change the shape of the data. So when we add a constant, the only thing that changes is the center. When we multiplying changes the center, or dividing. Multiplying and dividing changes the center of our data set, and it also changes the variability. It's going to change the standard deviation. So when you add a multiplier, you had to go ahead and apply that multiplier to the standard deviation as well. But still, it doesn't change the shape of the data set. Okay, so those were the things that we learned about adding a constant and multiplying by some constant b or some coefficient back in chapter 2. Today we're going to talk about how adding or subtracting a constant affects a data set when we're looking at it from a probability distribution standpoint. So now we're going to take a look at an example. It's Pete's Jeep Tours. Pete's Jeep Tours offers a popular day trip in a tourist area. Let C equal the total amount of money that Pete collects on a randomly selected trip. So we've looked at this example before, and we see that there's the number of dollars collected. And remember, this was the number of people. So if there's 2 people, 3 people, 4 people, 5 people, and 6 people was the max. So that's the amount of money collected. And this is the probability of each tour. Okay. This is a histogram of that probability distribution. So we've got a histogram listed out right there. C is money collected. And then you've got your probability over here on the left-hand side on the vertical axis. Now, what happens if you factor in Pete's costs? Because that's just the money that comes in. So it says it costs Pete $100 to buy permits, gas, and a ferry pass for each day trip. So let V be the amount of profit that Pete collects on a randomly selected trip. So his profit is now this. We had to take $100 away from all of those points. So when he had 2 people going on a trip, he made $300. But if you take $100 away from all of his costs, he's at $200. When 3 people went on his trip, he made $450. But if you take $100 away, he makes $350, and so on and so forth down the line. Take a look at the histogram. This is a histogram of that data set instead of the variable V, which is his profit. What do you notice about that histogram? Even better, let's take a look at them together. So this is the original histogram. This is the profit histogram. Okay, that's this one. So when I look at these 2 histograms, you should notice that the shape of the data set did not change. Okay, the shape of the data set did not change. You can also tell that the variability of the data set did not change. However, the mean is the only thing that's different. The mean of the profit is $462.50, which is $100 less than the mean of the revenue, which was, or the money collected, which was $562.50. So we had to take that constant and we had to subtract it from the graph because that's what our variable V was doing. Okay, subtracted from the mean of the first graph, I should say. The standard deviations, however, take a look. The standard deviations did not change. Standard deviations are the same, and the shape of the graph is the same. So all of this is to just show you or reinforce with you that when you are looking at a probability distribution, just like when we looked at frequency and when we looked at other data sets back in chapter 2, we talked about normal distribution back in chapter 2 a lot. When you are adding or subtracting a constant to a probability distribution, the measure of center will change. You have to add or subtract from the measure of center. So if you're looking at mean, median, the quartiles, or the percentiles, all of that shifts, okay? But the measure of variability does not change, okay? The range, the IQR, the standard deviation, it does not change. And then it also does not change the shape. So that's a good thing too. It says, note that adding or subtracting a constant affects the distribution of a quantitative variable and the probability distribution of a random variable in the exact same way. So when we looked at this in terms of just a quantitative variable back in chapter 2, it's doing the same thing to a probability distribution here in chapter 6. Okay, that's the good news. Now let's take a look at another example. It says, in a large introductory statistics class, the score X of a randomly selected student on a test worth 50 points can be modeled by a normal distribution with a mean of 35 and a standard deviation of 5. Due to a difficult question on the test, the professor decides to add 5 points to each student's score. Let Y be the scaled test score of the randomly selected student. Describe the shape, center, and variability of the probability distribution of Y. Okay, so the mean right now is 35. The standard deviation right now is 5. So let's write those down. And that's our variable X. So the mean of X is equal to 35. Standard deviation of X is equal to 5. Okay. I want to add 5 points. So my Y is going to be my X plus 5, which means that's going to turn this, the mean of Y, into 35 plus 5, which is 40. Oops, my equal sign, hello. So the mean of Y is going to be 40. The standard deviation, however, stays the same. So the standard deviation of Y, oops, not mean. Standard deviation, put the wrong symbol, sorry. My standard deviation of Y is going to stay 5. The other thing we need to talk about is the shape. You were told that this is a normal distribution. So the new data set, the probability distribution of Y, is also going to be a normal distribution. Of Y, the scaled score, yeah. Did they say approximately normal? Modeled by a normal distribution. So we'll just say is normal. There you go. So you've got the center, you've got the spread, and you've got the shape. All right, so now we're going to talk about multiplying and dividing by a constant in a probability distribution. And the good news here is that it's kind of the same as what we did in chapter 2 as well. So when we're multiplying or dividing each value of a random variable by the same positive number b, we want to multiply our measures of center, meaning the mean, median, quartiles, percentiles. We're going to multiply that by b. We also want to multiply the variability, meaning the range, IQR, standard deviation. So now this is where it's different than adding. So we have to actually change our variability, our spread, whatever we're looking at. But still, it does not change the shape of the distribution. So that's a good thing, okay? Multiplying or dividing by a constant has the same effect on a probability distribution as it did on a quantitative data distribution. All right, so let's take a look at this example. It says El Dorado Community College considers a student to be full-time if he or she is taking between 12 and 18 units. The number of units, X, that a randomly selected El Dorado Community College full-time student is taking in the fall semester is shown in the following distribution. So 25% of the students take 12 credits, 10% of the students take 13 credits, 5% of the students take 14, 30% take 15, 10% take 16, 5 at 17, and 15% at 18. There's our probability distribution. There's its histogram. At the rate of histogram of the probability distribution, the mean is 14.65. The standard deviation is 2.056. At El Dorado Community College, the tuition for a full-time student is $50 per unit. Wouldn't you like to go there? Doesn't that sound like a good idea? Anyway, if T, so now T is the variable we're adjusting. If T is the tuition charge for a randomly selected full-time student, T is equal to 50x. Okay, so there's our new variable with its equation, and I know I'm multiplying by things. So in part A, it says what shape does the probability distribution of T have? So notice that this is the probability distribution of X, okay? But one thing that we don't see a histogram of T. We haven't created that. But you know that when you multiply or divide by a constant, your shape is going to stay the same. So I can use this histogram to describe the shape of T because it's going to stay the same. So I would say, this is kind of a funky histogram. So I would say that this histogram is, it's approximately symmetrical. So the shape of T shape of distribution T, it's approximately symmetrical. But it's kind of weird because it's got those 3 peaks. With 3 peaks. Now here's the thing. We have to figure out what those peaks are because it's good to list those peaks out. And we're looking at the money side of it, not the credit side of it. So if I want 12, 15, and 18, bust out your calculator and multiply all of those by 50. 12 times 50 is going to be 600. 15 times 50 is going to be 750, and 18 times 50 is going to be 900. So I'm looking at dollars now for distribution T. Keep that in mind. This is distribution T, which is the dollars, the tuition cost. So with 3 peaks, at T equaling $600, and label your answers. That's going to be important. Context is always important. $750 and $900. That's what we're looking at there. All right, let's take a look at B. In B, it says find the mean of T. So in order to find the mean of T, I need to go back to that mean of X, whatever the mean of X was. So I'm going to go back and look at that previous slide, and I'm going to find the mean of X. And I was told that the mean of X is equal to 14.65. So that means that the mean of T is going to be equal to 14.65 times 50. Okay? So take that multiplier and multiply it by your mean. So 14.65 times 50, I almost typed in 60. There we go, 732.50. Mean of T is going to equal $732.50. So there's that. Again, don't forget to label your answer. That's going to be really important. And then C, last one, calculate the standard deviation of T. So the standard deviation of T, same thing. I go back and look at what the standard deviation of X was, which it was 2.056. And then I use that to find the standard deviation of T, which 2.056 times 50. 0.056 times 50, I get 102.8. So $102.80 is my standard deviation of T. Okay, so the bottom line is this is just kind of a refresher back from chapter 2. Adding and subtracting a constant does the same thing to our probability distribution as it did to our quantitative variables back in chapter 2. Multiplying and dividing, same thing. Multiplying and dividing by a constant does the same thing to our probability distribution as it did to our quantitative variables back in chapter 2. We're just also in the business of factoring in that probability piece, where when you find the mean, you have to multiply the value times the probability in order to find the mean at the end. Okay, so that's what makes this a little bit different from chapter 2. Otherwise, it's a lot of similarities. Thanks for tuning in, and I will catch you next time.